Nth Root Notes by Britney Thompson. The nth term is a formula that enables one to find any term of a sequence. It is used in mathematics and is applied to help one find the result without having to skip from one value to the next. It is used in the equivalent, either the constant difference sequence or changing difference sequence. The nth root is written as the square root of x. Find what n is when n to the square root of 625 equals 5. To solve this equation, you're going to raise 5 to the power of x. X in this case is 4. 5 to the power of 4 is 625. Solve this. Square root of x to the third power, y to the ninth, equals x to the first power, y to the third. To solve this, you're going to find the greatest common factor, which in this case is 3, and divide both sides by 3. Simplify the following problem. The square root of 16x to the fourth power, y to the 24th, gives you what? Find the greatest common factor, which in this case is 4. When you divide 16x by 4, you get 4x. When you divide the power of 4 by 4, it leaves you with 1. Y to the 24th power divided by 4 gives you y to the 6th power. By finding the greatest common factor of 4, we simplified the problem. What would you do when the number is not a perfect square? If you don't get a perfect square right away, keep breaking the number down. If the problem were the square root of 48, for example, you would keep breaking it down until you found that 2 can be factored into 48 4 times, which means that you can pull out 2 squared from the radical sign, making 4 a coefficient of the radical sign and leaving 3 inside. Here's how you do it. Take the square root of 48 equals the square root of 2 times 24. Then taking the square root of 2 times 24, you get 2 times 12 times 2. Taking the square root of 2 times 12 times 2, you get the square root of 2 times 6 times 2 times 2. Then taking the square root of 2 times 6 times 2 times 2, you get 2 times 3 times 2 times 2 times 2. Then taking this and putting it in a greater form, you get the square root of 2 to the fourth power times 3. Taking 2 to the fourth power times 3 gives you 4 to the third power. So there you have it. The square root of 48 is equal to 4 times the square root of 3. Remember that you cannot simplify a prime number that is under a square root. That is because a prime number's factors are only one in itself, so it cannot be factored or simplified any other way. For example, the square root of 17 cannot be simplified further because 17 is a prime number. Factoring a number with more than one perfect square. If the number's factors contain more than one perfect square, move them all outside the radical symbol. If you found multiple perfect squares during your simplification process, move all of their square roots to the outside of the radical symbol. Then multiply them. For example, let's say you're trying to simplify the number square root of 32. You can break it down to the factors 4 times 4 times 2. So the perfect square 4 appears twice. Just pull out, quote, 2 from each of the factors 4 to get 2 times 2 outside the radical sign. So the square root of 32 is actually equal to 4 times the square root of 2. Now, Don't confuse the coefficient with the nth root. 3 to the square root of 125, for example, is 3 times the square root of 125. But the power of 3 to the square root of 125 is the cubed root of 125. Since 5 times 5 times 5 is equal to 25, the power of 3 times the square root of 125 is 5. Know the factor is a number that can be evenly divided out by another number. For example, 2 is the factor of 8 because 8 divided by 4 is 2. But 3 is not a factor of 8 because 8 divided by 3 does not result in a whole number. For example, 5 is a factor of 25 because 5 times 5 equals 25. An easy way to find out whether your equation has a perfect square or not is to divide the radical and look at all the perfect squares, beginning with the one that is the next smallest compared to your radicand. For example, when looking for the perfect square that goes into 27, you might start at 25 and go down the list to 16 and stop when you're at 9. When you found the one that divides into 27, there you have it. When you have the equation, the power of 3 times the square root of 27, to break this down, find what goes into 27 and have a perfect square involved. So 9 and 3. Well, break those down even more. 9 is 3 times 3. So then you have the equation 3 to the 9th power.
That's cool.
For example, when you have the equation the square root of 64 x to the 8th power, y to the 16th power, break it down. 64 goes into 8 and 8. X to the 8th power divided by 8 is 1. Y to the 16th power divided by the square root of 8 is 2, leaving you with 8x y squared. When you have the equation 3 to the square root of 27p cubed, 9 to the 6th power, you get 3p cubed squared. P is what you would divide by, and 3. With the equation 4 times the square root of 16x to the 9th, y to the 12th, z, what you do, take the 4 on the outside and divide the 16x by 4. Divide the next x to the 9th, y to the 12th by 3. Leaving you with x squared, y cubed, and 4 times x squared inside the radical. The next equation, 3 times the square root of x to the 9th, 6th power, r to the 6th, 5 to the 7th, you get 2 to the 9th squared, r s, 2 times
Square
root of r squared c.
C.
Thanks for watching my notes